here is another example. Find the coordinates of the point of inflection on this curve. So the first step, or step one, is to find the first and the second derivative. So find the first and the second derivative. So the first derivative will be, so the first derivative will be e to power x minus 2x, and the second derivative will be e to power x minus 2. Now step 2 will be to set the second derivative equal to 0 and solve for the potential inflection point. Step 2, set the second derivative equal to 0 and solve for the potential point of inflection. So what that means is I take my second derivative, which is e to power x minus 2, equate it to 0, which means e to power x will be equal to 2. Now what you need to do here is rewrite from exponential form to logarithmic form. So if we do that, then we'll be able to find the value of x. What I mean is this. This will be equal to log to base e of 2 will be equal to x, which implies that x will be equal to ln of 2. Okay, so the potential point of inflection will be at x equals to ln 2, and we need to investigate further. We need to check for change in concavity, which leads us to step 3. So step 3 will be using the sine diagram to be able to check for change in concavity. So step 3 use sine diagram for second derivative to check for change in concavity. Which means we need to draw a sine diagram. So here we have ln2. These are x values. We need to investigate the sign of the second derivative. So we'll pick some test points on either side of ln2. For example, here we can pick ln1, and here we can pick ln3, and just try to figure out what those values will be. For example, if we plug in ln1 into that, so that will be e to power ln1 minus 2. So e to power ln1 minus 2, that's same as 1 minus 2, which is negative 1. Now from laws of logarithms, if you look at your formula booklet, this is the same as 1. Okay, so that will just be 1 minus 2 which will be -1. Okay, so anyway, so this will be -1, and this will be same as e to power ln 3 minus 2, which will be 3 minus 2, which will be equal to 1. Okay? So we have those, which means that on the left we have negative, here we have positive. So the sign is changing, which means this point x equals to ln2 is a point of inflection. So we can say concavity changes at x is equals to ln2, hence it is an inflection point. So it is an inflection point. Is that the end? No, we need to find the y coordinate. So we need to move further we need to move next to step 4 to be able to find the y coordinate. So step 4, find the y coordinate. So you just plug ln2 in the original function, this one here. So which means, and assuming this is a non-calculator paper, so you'll have e to power ln2 minus ln2 squared, which is same as 2 minus ln2 squared. Okay? And that will be the y coordinate. So which means that we can finally finish up. We can say that the point of inflection is, or we can say ln2 and 2 minus ln2 squared. So this, basically this point here is the point of inflection. Okay, so you can just leave your answer in that form.